Okay, finally, guys, we can get on to our next speaker, a man who told me when I asked him how he wanted to be introduced that I can make up anything. So here is my favorite developer of all time, Kevin Hoffman.
Can everyone hear me fine? It's all good? All right. Yeah, before I start, I just wanted to thank everybody for coming. I know it's hot, it's after lunch, everybody wants a nap. I also remember it wasn't all that long ago where it was just the two of us sitting in a coffee shop talking about WebAssembly, and that was because I told the barista my name is WebAssembly. How many of you have heard of WebAssembly before? That's really shocking. Last time I did this, it was nobody, but then again, last time I did this was pre-COVID, so I guess people have had a lot of time to Google WebAssembly since then. Is anyone running WebAssembly in production? One person, excellent. All right, so let's get started. I was hoping my made-up introduction would be more interesting, but this will do. So I am the CTO of Cosmonic. Cosmonic is a company that's providing a platform as a service on top of an open source project that I created called WASM and Cloud. I wrote a book called Programming WebAssembly with Rust, and I've basically been eating and sleeping and breathing distributed systems for well over the last 10 years. If I can get people to just think of one question that they want to ask at the end of the session about WebAssembly, then I'll feel like I've accomplished what I wanted to do. There's way too much about WebAssembly to fit into one session, so what I'm going to do is try and give a quick overview of what WebAssembly is, why do we care, and then how can we use it. And of course, all of this applies to outside the browser, just because I'm a back-end guy and don't do anything in the browser. So I think I am required by law to say that WebAssembly is neither web nor assembly. It's a portable compilation target, which is fancy words for it's a bytecode file that's interpreted by a virtual machine. It's already supported in every major web browser, and the web browsers are serving sort of as the test bed. So features make it into the browser, and then we get to take advantage of them in the cloud. And again, the WebAssembly specification supports running outside the browser, and that's really the purpose of this talk. So one of the things about WebAssembly that people like me find most appealing is what it can't do. It's an extremely limited technology, despite all of the smoke and mirrors you may have seen. The WebAssembly virtual machine format, when you want to call a function on it, you can only pass in numbers, and you can only get numbers back. Everything else above that is, again, smoke and mirrors. There's no bytecode instructions in WebAssembly for doing anything like opening a network socket, opening a file, accessing operating system services. Anything beyond just pure number crunching is something that the host provides. And so in some cases, the host is the browser. In other cases, the host is specialized cloud runtimes, which I'll show during a demo. In terms of functional programming, all of the side effects are things that are handled by the host. Again, required by law to show this tweet as well. The creator of Docker famously tweeted that if WASM or WebAssembly had existed in 2008, they wouldn't have needed to create Docker. So a lot of people like to say that WebAssembly is the next evolution of Docker, and they're not all wrong. So why do we care? Why do we care about WebAssembly outside the browser? First is that it's secure. There are a million reasons why WebAssembly is secure, but probably the one that people in the cloud find most interesting is, again, the only thing that a WebAssembly module can do is what the host lets it do. This has some subtle implications in that you no longer need to do code scanning. You don't need to do static analysis to figure out what your module is going to try and do. You know ahead of time, and you can block it from doing that. It's fast. It's a stack-based virtual machine. It's portable in that there are no, that the instructions inside WebAssembly are CPU and operating system agnostic. So as long as the host is conforming to whatever contract you've decided on, it can run anywhere. And that means anywhere from embedded systems, Raspberry Pis, various clouds, and obviously in the browser, mobile devices, fleets of trucks, all kinds of IoT applications are ideal for WebAssembly. And that brings me to small. When you're building WebAssembly modules, it depends on the language and the runtime and the framework, but most of the time, your unit of deployment is under a meg. And so that means that we go from shipping 2 gig Docker containers to shipping something that is 1/10 the size of the average meme we share in Slack. And again, it's safe. WebAssembly operates in a zero trust model. So like I said, the release artifacts for WebAssembly are tiny and portable. The main idea, oh, these lights are hot. The main idea is to ship code to the data and not data to the code. This is an optimization that all of us have been wanting for a long time, but with the prevalence of things like machine learning models, where you have expensive compute and massive amounts of data, you want to be able to ship the compute to the data rather than the giant data set to the compute. And there's no penalties for scaling on demand, because if your unit of distribution is now a meg or less, it becomes trivial to ship that unit of compute anywhere you want it to run. The WebAssembly's isolated sandbox forces us to separate side effects. Previous speaker mentioned how horrible the phrase non-functional requirements are, so I'll just leave that abbreviated. But the limitation of WebAssembly, that it forces us to separate our side effects, the things that the host needs to take care of for us, from our actual business logic. So this is a tiny little bit of assembly script. Has anybody used assembly script? I know a lot of hands went up for WebAssembly in general, but has anybody used assembly script? Okay, so we got one hand. So that's interesting. So assembly script is a JavaScript-like language that builds directly to WebAssembly. And we use the export keyword to indicate that we want the host to be able to call this function. So I'm in the cloud or on a Raspberry Pi or somewhere else, and I want to invoke this function. Then I just use assembly script. I can use assembly script to build this. Just fair warning, all of my demos are terminal windows. Like I said, I don't really believe in the existence of browsers, so if I take a look at my assembly script function, it's 3 lines. And the code to build it is just run assembly script against that file, and you build your WebAssembly file. And if you look, I don't know if the highlight shows up here, but my WebAssembly module is 92 bytes. which is a far cry from a hello world on a JVM virtual machine. So, like I said, the limitation that most people run into first when they deal with WebAssembly is that it only talks numbers. You see this hello world example a lot, and people just sort of gloss over the fact that if you want to do anything useful with any other data structure than 32-bit ints, you're on your own. So if I try and compile this in assembly script, this will not work outside the browser. If I go back to my demo here, let's see if I can. Like I said, I don't use browsers. So what I'm going to do is decompile the string version of that assembly script one, and then I'm going to look for the things that it needs from the host. Hilariously, the only thing it needs is abort, and the abort function doesn't come in standard cloud libraries. So what actually ends up happening is whatever tool I'm using generates this stuff, which is part of the smoke and mirrors that I was talking about, where just to deal with a string, we have to do something called lifting and lowering, where we send a number, which becomes a pointer into memory, and then we do all this nonsense in order to put the string into memory, and it becomes hideous pretty quickly. And again, that's JavaScript, which means now I'm tightly coupled to this non-existent thing called a browser. So what I want to do is free myself from having to deal with all of this JavaScript stuff, work on non-browser hosts, but still be able to use real data types. So now you've got, this is just a sample of some of the JavaScript that was generated. I'm not sure why I'm getting so much feedback over here. Has anybody used Rust? I'm going to guess the numbers are higher than JavaScript. Still not that high. Out of curiosity, the people that have raised their hands for WebAssembly, was that through C and C++, or just, okay, no hands for C or C++, not assembly script? All right, so Rust gives us some macros that we can use to stick onto our functions that make it look like we're dealing with strings and regular functions, but then I still need to run extra code generators to deal with it, and the output this should look fairly familiar, even though I'm using Rust and I'm using an entirely different set of functions. I've still essentially generated smoke and mirrors. I've got JavaScript that converts my high-level data types into numbers that WebAssembly understands. So I'm still out of luck in that I need to use generated code, and the generated code is browser specific. So the next thing I want to talk about is when people typically get to this point in the discovery phase for WebAssembly, and they realize that the only way they've seen it work in demos is people generating JavaScript and running it in the browser and pretending like WebAssembly is, or that their solution is portable, when if it only works in the browser, you've completely ruled out the main reason why WebAssembly is so important. If you take away WebAssembly's portability, you might as well not be using WebAssembly anyway. So the next thing that people need is a non-browser host runtime that gives you the ability to exchange high-level data types between the WebAssembly module and the host. And what WASM Cloud, which is a Cloud Native Computing Foundation open source project, what it does is it takes the concept of side effects and puts them behind strongly typed contracts. So in this case, we have an HTTP request handler, which returns a HTTP response. And this TinyGo code will compile into about a 30K WebAssembly module. What's missing from this is all the code to start a server, all the code to bind to a port, all the TCP networking code, all of the code for observability, for logging, for tracing, and pretty much everything else. This is pure business logic. And so if I wanted to do and want to access a key value store, I just call the increment function on key value, and the host runtime binds my WebAssembly module to an implementation of the key value contract. And at runtime, somebody is responsible for choosing which implementation of key value to bind. So this could be an in-memory cache on my laptop. It could be Redis in staging, could be Cassandra in production. The code not only never changes, but I never need to recompile it. So WASM Cloud is what I call a batteries included framework. It's opinionated, but it's also completely extensible. So in embracing the limitations of WebAssembly, it gives us an opportunity to turn that into an advantage with loosely coupled cloud capabilities and building portable, scalable business logic. So the WebAssembly modules that you build for WASM Cloud can deploy anywhere. Again, it's designed to push the code toward data. It participates in a flattened topology, self-forming, self-healing network. There's no need for deploying a discovery server or anything like that. As I said, the capabilities like key value store, web server, SQL database, message broker, all that stuff, those are all hot swappable at runtime. And if there's a capability you want to give to a WebAssembly module that we don't have either as our first-party providers or in the community, you can just build your own because the contract is public. It uses decentralized security. So one of the things that really bothered me about deploying Docker in production is that in order to validate a Docker image, I needed to consult some other authority. And if that authority was unavailable, I couldn't do anything. And the way WASM Cloud works is everything that a WebAssembly module is allowed to do is embedded in a cryptographically signed JSON Web Token inside the module. So there's no central authority, and so I can securely deploy and manage these modules even during network partition events. I can remotely control all of this, and my deployments are declarative and very similar to the way a Kubernetes deployment works. I can list off the WebAssembly modules I want to deploy, the capability providers I want and the configuration I want, as well as things like, I want to spread 100 instances of this actor across 10 hosts with this set of characteristics. And as I said, this is all part of the Cloud Native Computing Foundation. So what I want to do next is go to a demo, and again, I apologize to those of you who really appreciate shiny user interfaces. I don't. So right now, this laptop is using the local Wi-Fi, and at my house in the United States, I have another machine that's currently running that is part of what we call a lattice, which is the self-forming network. And in another firewalled network that I use just to keep the kids from sucking up my Netflix bandwidth, I have another machine running. And so I can use the remote controller so I have 3 hosts, none of which have a direct network connection to each other. Some of it is running over really low-powered Wi-Fi, and these all just coexist perfectly fine. These host IDs are public keys, so everything that we do is signed and secure. And we specifically chose this key mechanism to make it so that all of our keys are not only double-clickable, but URL friendly. So I can pass these public keys around anywhere I want to, and it's that easy. So theoretically, if this works, what I'll be able to do is start an actor, which is our Echo WebAssembly module, and an HTTP server. An HTTP server capability provider. And when I do start, I can choose the characteristics of the destination host that I want. And again, these hosts are virtual and logical, so I don't care whether it's running in Kubernetes or a Raspberry Pi on my watch. All I know is that one of these I want to deploy to a lab called Whopper, which is one of the machines at my house, and another one to a machine with the lab value of Mac, which is this machine right here. So I'll do these one at a time just because high chance of failure. So the other thing, while this is doing that, one thing to notice is the address for the unit of compute that I'm deploying is, it should look fairly familiar to anybody who has deployed Docker images. That is an OCI image reference, and it's actually sitting in a OCI compliant registry. Ironically, Docker Hub is the only one that doesn't support storing WebAssembly modules. You can use Azure Container Registry, you can use GitHub packages, you can use the Docker local registry image, you just can't use Docker Hub. But I can use, I can use our CLI to push and pull those images. So I can grab the inventory of a particular host, and you can see that that actor is running. The operating system type is Linux. This should start on my local machine. The image that I'm downloading, despite having cached it in the hotel several times, takes an awful long time to grab. But inside this host, you can see that I tried to make a request to start this capability provider. I'll give it a few more seconds before I give up. Like I said, this all worked from the Wi-Fi in the hotel room. What I find funny is that the actor deployed to my house just fine, and it's taking the capability provider here easily 10 times as long. But it's getting there. So meanwhile, I can So, as I said, it makes it easy that these keys are easily copyable. So I've actually got an HTTP server running locally on this Mac. I have an actor running in my house on the Nobody Touch My Netflix network. And in here, I know these aren't all that eye-pleasing, but public IDs make it nice and easy. What this command will do is link the actor to the capability provider with a configuration set of address equals, localhost 8080. So now that that link has been published, you should actually see, I'm sorry if you have to squint. If you're not right up here, you'll see that it started a capability provider on port 8080. So what just happened is I made an HTTP request locally to this Mac. It went and satisfied the request with a WebAssembly module running in my house. The answer came back, and then I got the results here. And when you start to think about why location transparency is so powerful, is normally when we're building distributed applications, we have to decide the final shape of our application at design time. Are we building a monolith? Are we building microservices? Are we going to build it as lambdas? None of those decisions should ever be design time decisions. I realize that may make me branded as a heretic, but those decisions should all be runtime. I should be able to run this application that I just showed you here as a monolith on my laptop when I'm testing, and then I should be able to spread it out across 1 or 2 machines in one environment, and then when I'm in production, I should be able to choose the number of instances of my actor that are running based entirely on external factors, like the number of requests per second or all kinds of other real-time metrics that get fed into my system. So again, I can actually show you some of the security as well. So go. So that command just went and looked inside the WebAssembly module and pulled out our secure JSON web token. And you can see I can set things like expiration dates, which I can't do on Docker images. I have an optional call alias, but more importantly, you can see that this particular actor WebAssembly module is allowed to talk to a key value store, and it's allowed to talk to an HTTP server. If it ever attempted to do anything else, it would be rejected. So again, I have portable compute that runs anywhere, at any scale, securely, and I can predict and control what it can and can't do. So WebAssembly is still changing. The specification, however slowly, is also still evolving. There are some new things in WebAssembly that I think are worth watching. The first one is, well, it should be the first one, is what's called the canonical ABI. Like I said, after you do just pure number exchange between the host and the guest module, somebody needs to agree on how you're going to send strings across or how you're going to send data structures across, and that agreement is called an ABI, the Application Binary Interface. And there is one available for WebAssembly. It's a fairly recent thing, and the interface types and component model, which are, I believe, both still proposals, those all depend on that ABI. And these slides will be available too, so no need to worry about trying to copy down those long URLs. So what I want people to get from this isn't that WASM Cloud is the best thing ever. I mean, it is, but that's not the point of the talk. What I want people to get from this is that you can start using WebAssembly now outside the browser, and if you choose the level of coupling that you get with the host, then you can set yourself up pretty well for the future. So if you use a host, something like WASM Cloud, then when the WebAssembly canonical ABI matures, WASM Cloud will just use that underneath, and your code won't have to care. If you know ahead of time that despite browsers being fictional, you are going to run it in a browser, then you can use tools like mscripten or AssemblyScript or the WASM bindgen tool for Rust. And as long as you're okay with the idea that generated code is still code that you own, then there's nothing wrong with doing that. If you want to do polyglot support code generation, there's this thing called interface types. And there's a DSL for describing the interface between any two modules, and that's called WIT. And there's a tool called WIT bindgen that does a lot of the smoke and mirrors generation that I showed you a little while ago, but in theory it's supposed to allow you to take that WIT file and generate an interface in whatever language you want in order to talk to that WebAssembly module. Today it only supports Rust and JavaScript, so do with that information what you will, but the plan is that that stuff is going to be more mature over time and more language support will be added. It's also completely open source, so as with most open source stuff, projects are born out of frustration, so if somebody wants a language binding badly enough, they'll contribute one. The only other caveat I have is with some of this Go code, Go's WebAssembly support, or TinyGo's WebAssembly support, is deceptive. It looks like it works, but you can very, very easily write code in TinyGo that will create a JavaScript binding, even though you never intended to. So it's just one of those things to look out for. Again, I'm assuming that situation is going to get better over time as well, but if there's one thing that people doing WebAssembly in Go find most frustrating, it's probably that. It's if you, like for example, if you use the JSON marshaller, it imports JavaScript. So I was hoping to leave some time for questions, so it looks like we have a few minutes. If you want to reach out, webassembly.org is the generic place to go. You can contact me on Twitter. There's WASM and Cloud and Cosmonic both have websites. We have a WASM and Cloud Slack. But really, I would love to hear any questions people have about anything from WebAssembly to WASM and Cloud or anything else.
Okay, so first a round of applause. Second, I present you with this thank you, and I'll put it just there in your hands. Thank you very much. And now I go over...
This is why we do this. I mean, you know, education is okay, but booze is where it's at.
And I will read out the questions. Seems like we've got a few. This one is very popular from Dominic. Are there standardized contracts for networking, etc.? Or is every host like WASM and Cloud defining own contracts, i.e. I'm vendor locked in?
So vendor lock-in, I'm not sure if my microphone stopped. Vendor lock-in is one of those things where if the benefits outweigh the lock-in, then vendor lock-in just becomes an opinion. Every single host right now, no matter who makes it, has a somewhat proprietary contract for doing whatever you want to do. All of the contracts for WASM Cloud are open source. They're defined in an Amazon language called Smithy. As I mentioned earlier, the plan is that once WIT and WIT BindGen and that whole ecosystem mature and everybody is using interface types and the component model, that'll become a non-issue and you'll be able to generate shims on either side for any contract you want. And that'll also include things like WASM Cloud. So vendor lock-in feels like a short-term consequence that comes from a lack of maturity in the ecosystem.
Okay, next up, we still have a little bit of time. Can we use Kubernetes to deploy WASM Cloud images?
Yes. There's two different ways you can do that. There's a project called Crustlet that actually lets you run a Kubernetes node that's capable of scheduling WASM Cloud modules. There's also the WASM Cloud host runtime is also available as a Docker image. So you can throw as many of those as you want into a Kubernetes cluster. They'll form their own network without any Kubernetes requirements underneath. And then you can use the WASM Cloud tooling to schedule the actors and capability providers on top.
Next up, what is the WASM Cloud trade-off besides the nascent ecosystem? Does it even exist?
So does WASM Cloud exist, or does the trade-off exist? Obviously, WASM Cloud exists. It's been around for 3 years. It's part of the Cloud Native Computing Foundation. The trade-off is that you're basically opting into WASM Cloud's opinion for how to do distributed application development. Our ultimate plan is to make it so that you can take all of the crap that we've been building that has nothing to do with features and shove that off to the side and deploy portable, secure, fast business logic. And like I said, as the underlying ecosystem gets better, there will be less and less that's proprietary WASM Cloud and more that's just bolt-on features.
Okay, last question. Remember, Kevin is here to answer all of your questions. Just come up and ask him. But the last one we'll do from here is there any widely used public service which is using WebAssembly in the background that you know about?
Cloudflare has, you can deploy WebAssembly modules as functions straight to their edge. And again, The trade-off is vendor lock-in. So if you deploy it to the Cloudflare edge, you can only use Cloudflare functionality on that edge. But there are a number of other ones that are working on various forms of WebAssembly in the background. Unfortunately, some of the coolest ones are ones I can't talk about.
Everybody, round of applause again for Kevin.
Thanks.
Thank you so much.